G'day lads, in this video I'll build an NBA player prop model in Excel that'll be able to calculate probabilities and equivalent odds for rebounds, points and assists so that you can compare them to bookmakers and identify value mathematically. If you want to download this model and use it every day, then click the first link in the description below to join hundreds of others and become a member of the Excel Lads Patreon. You'll also get access to every other model on this channel, including the MLB, NHL, European football and NFL models that I've built in Excel. Enjoy the video, lads. So lads, starting off with a blank worksheet, the first thing I'll do is import data I need for the model so that it can update every day without me having to manually copy and paste in new stats. And I'll do this using a Power Query in Excel to import 6 different data sets from the websites Basketball Reference and TeamRankings. Those links are in the description below. And the data sets I'll be using are NBA player stats, assist stats, NBA team stats, pace stats, which is the number of possessions per game, and then offensive and defensive rebound percentages for each team. That's their average throughout the season. And when I go back into the NBA player stats worksheet, I'll enter the text unique players in cell AG2, and then under that in cell AG3, I'm going to use a unique function on the range B3 to B1000 to return every single unique player name in this range. This is because some players are repeated if they've switched teams. And then I'm going to wrap this in a drop function where I'm going to drop -2 rows, and that takes off 2 rows at the bottom of the array. And then so I get every player from Giannis through to Cole Swider here in this array. And then scrolling across to the right in cell AH2, I can put the text current team, and this will return the current team for each player, even if they've switched teams throughout the season, because I want to be able to match a player to their team for the calculations later in the model. So I use an XLOOKUP function to do that. My lookup value will be AG3. I'll put the hash symbol next to it so it does it for every single row in the array. My lookup array is B3 to B1000. I'm finding the player in column B and then matching it in a return array to the value they have in D3 to D1000. So I'll put 2 commas. The match mode is going to be exact and the search mode is last to first. So that's -1. I'll close the bracket there and press enter. And before I do that, actually, I'll just absolute reference the 3 ranges there by putting a $ in front of the column and row so that if I ever drag the formula down or across, the ranges will stay the same. And then the teams update to spill an array that matches the current team for each player in column AG. Now I'll make some changes to the 2 power queries in the offensive and defensive rebound percentages from the website TeamRankings. So I'll put the text average in B33, and next to it I'll find the average of the offensive rebound percentages that each team averages from C2 to C31. And that's 24.78% in this instance. And then I'll do the same thing in the defensive rebound percentage worksheet, and that'll be again average in cell B33 and then the average in C33 using the exact same formula. And the reason I didn't go through the process of bringing in the power queries in this video is because it's very time consuming and different depending on your version of Excel as well as your computer. So if you want to learn how to do a power query, the video's on my channel, and of course there's other videos on YouTube. I'll then create a new worksheet called team names, and here the aim is to match each team name across the data set. So in column A there is team IDs, and that's seen in the basketball reference stats. For the team rankings data sets, they've got yet another name, and then in column B, I've got each team's full name. So make sure you pause the video now, write out this table so that later on in the video, you're able to match each team's stats across different data sets. Now you can make a new worksheet called result, and here is where we'll be able to select each player, their opposition, whether they're playing at home, or their multipliers will come up, and then the expected rebounds, points, and assists will be produced. So merge and center the cells B2 to D3, copy and paste into B4, put the text player in opposition, merge and center the cells E2 to K3, and do the same in E4 to K5. Now merge and center the cells L2 to M3, copy and paste into L4, and then do the same thing in columns N and O. Now put borders around it, and I need to come up with a drop-down list to select the player now. And to do that, select the cell I need to, go into the data tab, and in data validation, I need to allow a list. The source for that list will be the list of unique players I came up with in the NBA player stats worksheet. So that's AG3. And then you can put the hash symbol next to it, which spills the entire array as the list we can select. So if I click on that little icon in the top right, I can scroll down and select a player there. I'll put LaMelo Ball, and I can do the same thing when selecting his opposition. So go back into data validation, allow a list, and this time I want a drop down list of every team he could face, and that's in the team names worksheet from B2 to B31. So I'll press enter on that, and then I can select his opposition from the list here, and I'll put the Lakers to start off with. Now with his expected minutes played in this model, it's just going to be the minutes he's averaged so far this season. And to do that, I'll look up LaMelo Ball's stats using the XLOOKUP function. My lookup value will be E2. I'll look up E2 within the list of players in column B from B3 to B1000. And then I want to return his average minutes played in the NBA player stats dataset from Basketball Reference, and that'll be from H3 to H1000 of the same worksheet. I'll absolute reference this using the shortcut Command T on Mac, and I'll press enter on that. So LaMelo's been averaging 34 minutes so far this season. Later on in the model, I'll show you how to change this so that if he's expected to play less minutes, how that'll update the expected rebounds, points, and assists. Now I want to do another drop-down list for cell N4. And for this, I just want to list the two names, yes and no. So he's either playing at home, yes, or he's playing away. In that case, I'll put no. So now I need to come up with some multipliers to work out the expected rebounds for LaMelo against the Lakers. And from column E across to column L in row 7, I'll put the text home advantage, average offensive rebounds, average defensive rebounds, minute percentage, player team ID, a pace adjustment, an offensive rebound adjustment, and a defensive rebound adjustment. So all of these except the player team ID will be multiples that'll be applied to LaMelo Ball's average rebounds to find his expected rebounds for the game. So for the home advantage cell, it'll be an if function. If N4 is equal to yes, then return the square root of 1.01. If not, return the reciprocal of that, 1 divided by the square root of 1.01. Close the bracket, twice press enter, and this will return a home disadvantage if he's away, which is a multiple of 0.995. And if I change it to home, this will turn into an advantage of 100.5%. So a total advantage of 1% whether he's playing at home or away. Now for his average offensive rebounds, I'm going to use an XLOOKUP function to look up LaMelo within the list of players, again in the basketball reference dataset in column B from B3 to B1000, and then return the column for his offensive rebounds, and in this worksheet that's in column V. So the return array is V3 to V1000, and then I'll just absolute reference the lookup array and return array in here by putting a $sign in front of both the column and row, just so that if the query expands from the website, then I'm still getting the columns I want. So the average offensive rebounds for LaMelo is 1.0 so far this season. And I'll copy the first part of the formula because we'll be using that bit quite a lot throughout the rest of the video. And in the average defensive rebounds, I'm looking up the same player in the same range in column B. But this time I'm returning the column immediately to the right, column W, for the defensive rebounds he's gotten so far this season. Again, I'll put a $sign in front of both the column and row there. And then I'll return his defensive rebounds, which will be 4.4 so far. Now for his minute percentage, this multiple will indicate how much of the game he's expected to play based on his expected minutes. And so that'll be equal to N2 divided by the average number of minutes he's played so far this season, where the return array is, of course, H3 to H1000, as we've already done in cell N2. So right now, we're dividing N2 by the formula for N2, which is itself. So something divided by itself is always 1 or 100%. But if I manually write over the top of the expected minutes played formula in N2 to say 20, then that minute percentage changes and that multiple of 0.588 will be applied to LaMelo's expected rebounds when we calculate that later on in the video. So for the player team ID, I need to return the team the player selected is playing for and their 3-letter abbreviation according to the Basketball Reference dataset in the NBA Player Stats worksheet. So I'm looking up E2 in the AG3 array and returning the array immediately to the right, AH3, and put the hash there, of course, because you need that to spill the array. And then, of course, right now LaMelo plays for the Charlotte Hornets, but if I change the player selected in E2, that team will update as well. Now for the pace adjustment, that'll be a custom formula that will take into account the expected pace of the game. If there's going to be a faster game with more possessions, then we can expect LaMelo will pick up more points, rebounds, and assists. So the formula for that is the square root of 2x lookup functions, where I'm looking up I8, the 3-letter team abbreviation in A2 to A31 of the team names worksheet, and returning the team rankings name in C2 to C31 of that worksheet. Now, once I get that name, I'm looking that up in B2 to B31 of the 24-25 pace worksheet, and then returning the corresponding pace value in column C. Then I'm multiplying this by another 2 XLOOKUP functions, where I'll do something very similar. This time I'll look up E4 and I'll return the lookup array of B2 to B31. So this is the opposition now, and comma, I'm going to return their team rankings name, close the bracket there. And then once I've got that, I can look up the team rankings name back in the 2024-25 pace worksheet from B2 to B31, and then return the pace in column C again, C2 to C31, close the bracket there. Once I close the bracket again to finish off the formula, I'll divide by the second part of the formula we just did, the 2x lookup functions, looking up E4, and then returning the pace for the opposition. So the total formula is the pace of the selected player's team multiplied by the pace of the opposition divided by the pace of the player selected's team. So that gives a multiplier which can be applied to the expected rebounds, points, and assists for a player, because again, if there's more possessions in a game, then you can expect more points, assists, and rebounds for a player. Now to come up with an offensive rebound adjustment multiplier, that's going to be equal to bracket 1 minus, and in brackets, x lookup. The lookup value will be the opposition in E4, comma, going into the team names worksheet, looking them up in B2 to B31 and returning the team rankings name in C2 to C31. Now with that name, I'm going to use that as the lookup value in the next x lookup function, where I'm looking that up in the lookup array defensive rebounds B2 to B31, and then returning the defensive rebound percentage for that team so far this season, closing the bracket 3 times, and then dividing by the average offensive rebound percentage in C33. And what this formula does is it finds the defensive rebound percentage of the Wizards, in this case, the opposition, and subtracts that from 1. So we can expect a high amount of offensive rebounds the Wizards concede in this case. This is then divided by the league average offensive rebound percentage to be a multiplier, so that if a team concedes more rebounds than expected, that means the expected rebounds for the player selected will increase as well. So for the next formula, defensively, it's 1 minus an XLOOKUP function of an XLOOKUP function, where I'm looking up the opposition in E4, returning their team rankings name in column C, using that as the lookup value in the next lookup function, where I'm looking them up in the offensive rebound percentage worksheet, B2 to B31, returning their value in C2 to C31, closing the bracket 3 times, and then dividing by the average defensive rebound percentage in C33. So again, I'll reduce that to 2 decimal places. And in this case, the Wizards concede more offensive and defensive rebounds than the league average team. So the multipliers are both above 1 to be applied to LaMelo Ball's average rebounds when calculating expected rebounds later on. So now I'm going to copy and paste the headers for those multiples from row 7 into row 10. And these will be for the expected points now. I'll name these multipliers average field goal attempts plus free throw attempts, 2-point attempts possession share, 2-point percentage, 3-point possession share, 3-point percentage, free throw possession share, free throw percentage, and a points adjustment factor. So now for the average field goal attempts and free throw attempts for the player, I need to do 2 XLOOKUP functions where I look up the selected player's average field goal attempts and then add another lookup function that returns their free throw attempts so far in this 2024 to 25 season. So that'll be XLOOKUP, looking up the player in E2, looking them up in the B3 to B1000 range in the NBA player stats worksheet from Basketball Reference, and then returning their field goal attempts in column J of this data set from J3 to J1000. I'll absolute reference this, and then I'll also copy the first part of the formula, because for, I think, every formula in row 11 for the expected points, I'll be needing the first part of the XLOOKUP function. So I'll add that XLOOKUP function again, and this time return column T of the data set, the free throws attempted, so I can get the total number of shots attempted by this player so far this season. And LaMelo averages 30.1 shots of any type. Now for the 2-point attempt possession share, as well as the 3-point and free throw in columns H and J, I need to find the percentage of shots taken that are 2-point attempts in this F11 cell. So if LaMelo takes 30 shots and 10 of them each game average to be 2-point attempts, then this should return 33.3%. Now the formula for this is going to be an XLOOKUP function, looking up E2 and B3 to B1000, and then returning the 2-point attempts from P3 to P1000. I'll then close the bracket here, open the bracket, and then divide by the number of 2-point attempts, this formula. So I'll copy that in and paste it right after a bracket, plus the number of 3-point attempts, plus the number of free throw attempts. So the number of 3-point attempts will be returned in column M, and then I'll copy this formula again and then change P to the free throw attempts in column T. So I'll close the bracket there. So this is the number of 2-point attempts divided by the number of 2-point attempts plus the number of 3-point attempts plus the number of free throw attempts. And when I do that for the 3-point share and free throw share, I'll just change the 2-pointers attempted to 3-pointers and free throws respectively. So the sum of that should equal exactly 1. Now for the 2-point percentage, I'm just returning the number of 2-point attempts that are successful. So LaMelo makes 51.4% of his 2-point attempts and converts that into 2 points. And the return array for that is in column Q. Now I'll copy and paste the formula text in cell F11 into H11 for the 3-point attempt possession share. And all I'll change here is change P3 to P1000 to M3 to M1000 in the numerator of this formula. And we can see that LaMelo takes 43.9% of his shots and does a 3-point attempt with them. Next, I'll copy and paste the formula text from G11 and paste that into I11 and change column Q to column N for the return array to return the success rate of LaMelo's 3-point shots. We can see here he makes 33.9% of those. Next, I'll copy and paste the formula text from H11 into J11, and here I'll do a similar thing. I'll change M3 to M1000 and instead return T3 to T1000, which is the free throw attempts he's done. You can see 18.3% of his shots are free throw attempts, and if I sum F11, H11, and G11 up, it's equal to exactly 100%, which is what we want. Next, I'll copy and paste the formula text from I11 into K11. Now the free throw success rate value is in column U of the NBA player stats data set. So that's U3 to U1000. And I'll change that to a percentage as well. Now for the points adjustment multiplier, that's very similar to how the offensive and defensive rebound adjustments were calculated as well. So I'll look up the X lookup of E4, finding the opposition in B2 to B31 of the team names worksheet and returning their team rankings name, and then using that output in another X lookup function to look up the team rankings name returned within the lookup array of B2 to B31 in the NBA team stats worksheet. Again, the link to all these data sets is in the description of this video, and then return the average points conceded for that team in C2 to C31, and then finally divide by the average of C2 to C31. And here we get 1.09, and that means the Wizards concede on average about 9% more points than the league average team. So when we're calculating the expected points for ball, that'll increase by 9%. If we change it to a stronger team this year, the Celtics, 0.96 means they concede 4% less than normal. So that expected points figure will be reduced for ball. Now copy and paste the headings average assists and assists adjustment into row 13 for columns H and I. Then I'll copy the formula text in cell G11 into H14, and then change the return array to Y3 to Y1000 to get the average assists for the player selected in cell E2. And then for the assists adjustment multiplier, that'll be another X lookup within an X lookup. So here I'll look up the opposition within the lookup array B2 to B31 of the team names worksheet. And then of course, again, I'll return their team rankings name. So that's in C2 to C31 of the same worksheet. Close the bracket. Now the lookup array, I'm looking up the output within the B2 to B31 range of the NBA assist stats worksheet, and returning the average assists conceded for each team in C2 to C31 so far that season, and then dividing by the average of that return array in C2 to C31. So here the Boston Celtics are relatively good at conceding 9% fewer assists than the league average team. If I change the team selected, say to the Trailblazers, on the other hand, they're not as good. So they concede more assists than the league average team. So the multiplier is above 1, and LaMelo Ball, or the selected player, will have an increase in their expected assists when we calculate that later on. So now in row 16, I'm going to merge and center the cells B16 to C16, as well as D16 to E16, and copy and paste that into columns G through to J and L through to O, and then name them expected rebounds, expected points, and expected assists. I can also go into view and get rid of the grid lines so the worksheet looks a bit neater. And now it's time to use formulas with the multipliers we've calculated above to come up with expected rebounds, points, and assists for the player selected, taking into account their opposition and whether or not they're playing at home. So for the rebounds, it's E8, the home advantage, multiplied by F8, their average offensive rebounds, multiplied by the minute percentage in H8, multiplied by J8, the pace adjustment, multiplied by K8, the offensive rebound adjustment. So that's the expected offensive rebounds for LaMelo Ball. Now I've got to add the expected defensive rebounds, and that's equal to E8 by G8 by H8 multiplied by J8, and then finally you've got to multiply by L8, the defensive rebound adjustment, and that'll give you expected rebounds after they've been taken to 2 decimal places of 5.38. Now, of course, this is all depending on the multipliers above. If I change the player to somebody who averages a lot of rebounds like Wembanyama, then the rebounds figure will adjust. Now I can type out the formula for the expected points, and that's equal to the number of shots that player averages in E11 multiplied by the point adjustment in L11 multiplied by E8, the home advantage, multiplied by H8, the minute percentage, then finally by J8, and then you're multiplying that in a formula within brackets, which is equal to F11 multiplied by G11 multiplied by 2 plus H11 multiplied by I11 multiplied by 3, which is the expected number of successful 3-point shots plus J11 times K11, and then multiplied by 1, which means we don't need to do anything. So close the bracket and put that to 2 decimal places. So Wembanyama is expected to have 25.96 points in this formula, and then the expected assist formula in N16 is pretty straightforward. That's just equal to E8 by H8 multiplied by J8, and then you're going to multiply by H14, and then finally by I14 next to it, the assist adjustment factor, and then reduce that to 2 decimal places, and the expected assist for Wembanyama is 3.97. So these 3 are the expected figures for the players selected, taking into account their opposition and home or away status, as well as the expected minutes played. If you have a line that's above or below this, you can tell which line is most likely, but we don't yet know what the percentage of each figure is going over or under a certain line is. So to do that, we need to find and use an appropriate probability distribution for all 3 markets. And what you're going to do now is copy and paste B19 to E21 into columns G through to J and L through to O, where I've merged and centered the columns D and E into one cell here for the line. I can reduce that to 1 decimal point. And here I've got to find the probability of the expected figure being over or under the line. Now, lastly, before I do that, I want to have a drop-down list that determines what kind of odds they return for the expected value calculations, and I'll allow a drop-down list from N7 to 08 of either American or decimal odds. Now for the over, I'm going to use the Poisson probability distribution for the expected rebounds and expected assists. I've written an article about that. That's in the description below. And the formula for this is equal to let. The first name is going to be called percentage, and the value for this is an if error function. 1 minus the Poisson dot distribution function, open bracket, the x is the line in D19, the mean is the expected figure in D16, and the cumulative is true. Close the bracket, comma, 2 speech marks, close the bracket, comma. Now the final argument, which is what we're returning with the let function, is going to be an if function, where if N7 is equal to, in speech marks, American odds, then comma, return if percentage, which is the name we defined earlier, is less than or equal to 0.5, then return in speech marks the plus sign space, close the speech mark, and the round function, where you're going to open 3 brackets, the number is equal to 1 divided by the percentage, close the bracket, subtract 1, close the bracket again, and then multiply 100. The number of digits you're rounding to is 0, so close the bracket there. Now the value if false, so I'm going to add a comma, is equal to speech marks, negative sign, space, close the bracket, and a negative round function where the number is negative 100 divided by, in 2 opening brackets, 1 divided by percentage, close the bracket there, and then you're going to make sure that you subtract 1 again, close the bracket, the number of digits you're rounding to is 0, close the bracket twice, and the final value if false is 1 divided percentage again, which is the format for decimal odds, close the bracket there, and when I press enter, what this formula is doing is calculating the probability of the rebounds being over 9.5 according to the Poisson distribution, and then converting that into equivalent odds using either American or decimal odds, whatever's selected in cell N7 of this worksheet. So to do the same thing for the under, I can copy and paste this entire formula into cell N21. Before I do that, you can see if I change the line in D19, then the Poisson distribution recognizes that, sees that there's a smaller chance of the rebounds being over the line of 10.5, considering the average or the expected figure is 10.52, and then the odds become smaller, so the equivalent odds become higher. and they turn into plus 107. So I'll copy the second part of that formula there. It'll be equal to equals let. Now the percentage will be Poisson.dist. The x will be the line in D19. The mean will be D16 and the cumulative is true. Close the bracket there. And comma, I'm just going to paste that if function, which is found in the cell above, D20. And when I press enter on that, it'll be exactly opposite. So when a line is 10.5, because you can't get 10.5 rebounds, it has to be either 10 or 11. It's discrete. Then the odds have to be exactly opposite. And I can copy and paste D20 to E21 into cell N20. And it'll do the same thing for the assist market using the same Poisson probability distribution. And when you change the line, you can see the equivalent odds. So for example, with the over, if a sportsbook were offering odds of minus 150, then that would be a value bet because they're undervaluing the chance of that happening. And so in the long term, you could expect a profit, assuming the model is correct. But for the expected points, we can't actually do that because the probability distribution is different. There's 3 different types of shots, each with their own probabilities. So we need to create a new worksheet called point simulation. In A2, put the text trials, and below that spill sequence 1000, which spills the numbers 1 through to 1000. In B1, put the player in E2 and space simulated points in speech marks. So it'll return the player next to the text simulated points. And in cell B2 here, I need to simulate the number of points the selected player gets. Here it's Jason Tatum by splitting it up into 2-pointers, 3-pointers, and free throws. So to start, I'll simulate the number of 2-pointers Tatum makes. So that'll be equal to 2 times the number of successful 2-pointers. Binomial inverse within a binomial inverse within a binomial inverse. In the first one, there's 10,000 trials. The probability S is the probability of success, and that's going to be equal to result E11, the average number of shots the player takes, multiplied by the home advantage, multiplied by the minute percentage in H8, multiplied by the pace adjustment, and then you're going to finally multiply by the points adjustment in cell L11. And so once you've done that, select that and absolute reference it by putting a $ in front of both the column and row so that when I drag it down for the other formulas, the cells don't move, they stay constant. And then divide that by the number of trials, comma, rand for the alpha argument, that's open bracket, close bracket. And then I can close the bracket for the first binomial inverse function. Now for the second, the probability S is going to be equal to F11 in the result worksheet. And then I'm going to randomize it again. This simulates the amount of 2-point attempts the player will make. And for the final binomial inverse function, I'm using G11 as the probability of success. And that'll simulate the amount of successful 2-point shots the player makes. So it simulates the number of shots, then the number of 2-point attempts, then the number of 2-pointers made. So I'll do the same thing for the 3-pointers now. 3 times binomial inverse within binomial inverse within the binomial inverse again. The probability of success after 10,000 trials is going to be E11 multiplied by E8 multiplied by H8 again multiplied by J8, and then it's the same thing as before, multiplied by L11, the points adjustment multiplier. And then I'll divide that by 10,000 again, and then randomize it with an alpha. And then what I'll do is I'll make sure that the H11 figure is the probability of success to simulate the number of 3-point attempts. And I'll randomize that to, comma, and then I want to simulate the number of successful 3-point attempts. And that's in I11 for Jason Tatum. And I'll randomize it again with the ran open bracket, close bracket function. Now, lastly, I need to simulate the number of successful free throws. So because a free throw is worth 1 point, I don't need to multiply it by anything because 1 is 1. So 3 binomial inverses again. And yet again, I've got to do the same thing. So it's going to be E11 multiplied by E8 multiplied by H8 and J8, then L11 in the result worksheet. for the probability of success, and then I'll divide that by the number of trials yet again, which is 10,000. The reason the trials is 10,000 is because the binomial distribution approximates the Poisson distribution for large numbers. So that's a reason why there's 10,000 trials. The rand function is used for the alpha, comma, J11, we're simulating the number of free throw attempts Tatum makes, rand, open bracket, close bracket, and then we're simulating the number of successful free throw attempts using K11 as the probability of success, rounding off the last binomial inverse function. And then when I simulate the different points, you can see how it changes. I can always just drag this formula down 1,000 times, but I'll select the range A2 to B1002 so that I can use the data table in what if analysis. I will skip the row input cell, and for the column input cell, just put something outside of the data set like E6. And then when I scroll down, this does the formula in B2 1,000 more times using an array function. And this simulates what Jason Tatum can do in a game according to the multiples we've put in the result worksheet and the randomized binomial inverse function. Now to find the probability of going over or under, it's super easy. We've just got to count the amount of times Tatum's points in the simulations are over 26.5. And so to do that, I'll copy and paste the formula from D20 into the over and change the percentage chance to a sum product function, open bracket, 2 negatives, open bracket again. I'm counting how many times in the points simulation worksheet that the values in B3 to B1002 are greater than the line set in cell I19 above it. So close this formula with 2 brackets and then divide by 1,000 the number of trials, press enter, and then the over market has equivalent odds of -170. And to get the odds for the under, I'll copy and paste the formula text into the cell below, and the only thing I'll change is the greater than sign to a less than sign, because now we're doing the under points market. So you'll notice that when I refresh the cells, that the over and under markets will change for the expected points, but not for the rebounds and assists. That's because the points are, of course, simulation based. We're only doing 1,000 trials in this model. If you want to increase the trials to improve accuracy by reducing variance in these simulations, you can do that, but you've got to be careful of the model lagging too much, because simulations do use up a lot of processing power and can make the model a bit slower. So this model is all done now, lads. If you want to update the data in the Power Queries, go into the Data tab and select the Refresh All icon. This will update all the worksheets to bring in the newest stats into the model. I'll test it out one more time. If I want to change the player to, say, Damian Lillard, let's say he's facing the Lakers and the game is not at home. That is, they're playing away at the Lakers. His rebounds, points, and assists come up. Then you can change the line to see the equivalent odds, and if you trust the accuracy of this model, make expected value bets. If you want to download this model, then make sure you click the first link in the description below to go to the Excel Lads Patreon, so that you can use this model every day along with every other model I've published on YouTube and become better at building sports models in Excel. Thanks for watching, lads.